Hi guys, in our example today, question number 2 in simple gas laws, it's a pretty straightforward question. We're going to see how we can incorporate a different gas law now in order to find the volume of a container. So we talked about Boyle's law in question 1. Now we're going to talk about a different kind of law here. So in our case over here, we have a balloon that was inflated at room temperature at 25 degrees Celsius. Now this balloon contains a volume of 2.2 liters of air. One thing we have to know about this example is that pressure is held constant and the amount of gas in the balloon is held constant. Now what happened here is that this balloon was exposed to the outdoor temperature, which was negative 15 degrees Celsius. Now the observer noticed that the balloon shrinked in size. But we know that there's no air leaking, and there's the same amount. Sorry, there's no air leaking, and so there's the same amount of gas in the balloon. And we also know that the pressure is not changing. So why did the balloon shrink? Well, in order to know why, we need to know which gas law we should incorporate here. So we know that the pressure is constant and the amount of gas is constant. So it's not related to Boyle's law, because Boyle's law studies the pressure fluctuation with respect to volume. So in this case, it would be Charles' law. Charles' law states that volume and temperature are directly proportional. So volume and temperature are directly proportional. What does that mean? This means that when volume increases, temperature increases. And when temperature increases, volume increases as well. So we know here, it's usually the second case, by the way. It's usually when temperature increases, volume increases. So if we want to represent it by an equation, we would represent it this way. So what does that mean? This means that if we change the conditions of the volume and temperature, but we kept the pressure and the amount of gas constant, the ratio of this should give you a constant number. So this we could write in the form of V initial over T initial equals V final over T final. So now, let's plug in our values and see where this equation takes us. So, if we reorganize this equation to find the volume final, the result would be T final times V final is equal to T final, V initial over T initial. Now the trick here that most students fall in is the fact that the temperature is given to us in Celsius. Now, one thing you have to know is that when you're dealing with temperature, you're dealing with gases, the temperature is always written in Kelvin, unless otherwise stated. But for when using gas laws and ideal gas laws, you have to convert it to Kelvin. So in this case over here, let's switch up the values. Now we know that temperature in Kelvin is equal to temperature in Celsius plus 273. So for our first temperature, 25 degrees Celsius plus 273, that would give us 298 Kelvin. For the other one, negative 15 plus 273 would give us 258 Kelvin. So let's plug in the values over here. The temperature final is 258 Kelvin times volume initial was 2.2 liters over temperature initial was 298 Kelvin. So if you do the calculation, you get rid of the units and you're left with liters. If you do the calculations, you would end up with 1.90 liters. So now we know that the volume got reduced by 0.3 liters, and this explains why the balloon shrank from 2.2 liters, or from this size to this size over here. So now you know how to incorporate Charles' law, and you have to relate what you have given as constant and what you have given as variable in order to decide which law you should use.